Hi, this is Dan Lynch. Join me and Aaron Newcomb for FLOSS Weekly. This time we'll be talking to Micronaut, a serverless web framework that targets the JVM. That's coming up next on FLOSS Weekly.
Netcasts you love.
From people you trust.
This is Twit.
This is FLOSS Weekly, episode 537, recorded Wednesday, July 10th, 2019. Micronaut. This episode of FLOSS Weekly is brought to you by Worldwide Technology. Worldwide Technology's Advanced Technology Center is like no other testing and research lab, with more than $500 million of equipment, including solutions from key partners like VMware, and it's virtual so you can access it 24/7. To learn more and get insights into all that it offers, go to wwt.com/twit. It's time for FLOSS Weekly, the show about free, libre, open source software. And the observant people among you will have noticed already that I am not Randall Schwartz. I am your substitute teacher for this week. My name is Dan Lynch, and I'm going to be hosting today. Randall's a little under the weather, so best wishes to Randall. He'll be back very soon, we're sure, and we send him our best wishes, of course. And thankfully, I'm not here on my own. Thankfully for you, and thankfully for me, I'm not here on my own, because I'm joined today by another lovely and talented co-host, as Randall likes to call us all, Aaron Newcomb. Aaron, how you doing?
Hey, Dan, good. How are you doing?
I'm pretty good, yeah. It's been a while since we've been on a show together, I think. I mean, I can't know exactly how long, but it feels like it's been at least a few months.
At least, if not more, if not longer. I know being a co-host, we talk and email and stuff, but we never actually get to be on the show together unless we're doing some sort of roundtable or something like that. So it's nice to be on the show with two co-hosts this time. We get to actually talk and hear from each other directly.
Yeah, in real time. So exactly. I'm calling in from my studio near Liverpool in the UK, in the northwest of the UK. Looks like you're at home. Where are you talking to us from?
Yep, this is my usual call-in spot when I'm at home. This is my office area, messy office area, with books and stuff in the background, and then my makerspace stuff is all this way, so you can't see it. But you can see some of my old systems back there, some of my vintage systems. There's a Commodore 64.
I was just going to say, is that a Commodore 64?
Yeah, sure is. There's a VIC-20 back there.
Wow.
Yeah, all kinds of different systems, so.
I used to love the Commodore 64. That jumped out right to me. My friend had one of those when I was in school, and we used to play all kinds of games on it and spend hours on that. And then we got into the Spectrum. Over here was my big thing, the ZX Spectrum, and many others. But anyway, we're not here to talk about classic computers, although maybe someday we will be. Who knows? So stay tuned for Retro Computing Weekly or something. We're here today to talk about Micronaut, which is a web framework which targets the JVM. And as you can tell, I've basically had to try and get up to speed on this quite quickly because I was relying on Randall to ask the in-depth programming questions. So that's going to be fun. But have you had any chance to look at Micronaut or any of the things around it, Aaron?
I have not. I'm just looking at the website now, actually. So everything that I know about it has come to me in the past 5 minutes. But I do know a little bit about microservices and serverless applications. Certainly, it's something that we support at work in terms of APM. And so as I was kind of scrolling through here, all of this stuff is making sense. And so I'm actually really curious specifically about the serverless, what this can do for serverless functions, serverless microservices, whatever you want to call them. Because that can be a little bit of a problem for people knowing how to roll out their code effectively and efficiently for serverless. So, yeah, I'm curious to see what Micronauts can do in a serverless environment for sure.
Excellent. And it's great to have somebody who knows about the serverless stuff and can really get into that as well. It's something I've just kind of dipping my toes into, I suppose. So it'd be great to find out more about that. And of course, the reason we have these guests on is to tell us about these projects. I mean, that's why we're going to get to learn today, and hopefully people at home will get to learn too. All right. And so before we get into that and before we bring on our guest, I do need to tell you about our sponsor for today. This episode of FLOSS Weekly is brought to you by Worldwide Technology. WWT began began building their Advanced Technology Center, the ATC, 10 years ago, and it has grown exponentially. It's like no other testing and research lab. The lab contains more than $500 million in equipment, from hundreds of OEMs ranging from high-tech heavyweights like VMware, Dell EMC, and Microsoft to emerging disruptors like Equinix. WWT is a trusted partner who stays with you over the years. Many of their customers have been with them for over a decade because they know WWT is where they can go to get the answers they need to make sure their business runs right. And their ATC incubator has all kinds of great stuff going on. There's hundreds of on-demand integrated solutions labs representing the newest advances in network virtualization, software-defined data center, security, digital workspace, multi-cloud architecture, and automation, and more. Learn about these products before you launch. WWT's engineers use these environments to quickly spin up proofs of concept and pilots using the sandbox so customers can confidently select the best solutions for them. In many cases, this reduces concept time from months to weeks, which increases the speed to market. They also offer a lab as a service, a dedicated lab space within ATC. Here, customers can perform programmatic tests using the vast technology ecosystem that WWT has already built. It's virtual, so you can take advantage of ATC's unique benefits from anywhere in the world, 24/7. Which is awesome. WWT engineers work in these labs every day, beta testing new solutions based on the latest and greatest VMware technologies and building reference architectures and custom integrations to help their customers make decisions and see results faster. This summer, WWT will be launching a new digital platform with hands-on access to more than 200 lab environments. To learn more about WWT, the ATC, and get insights into their newest features with demos and labs, you need to go to wwt.com/twit. That's wwt.com/twit. WWT, delivering business and technology outcomes around the world. And we thank them for their support of FLOSS Weekly. All right, then. So with that done, we should go ahead and bring on our guest. And today we're talking to Graeme Rocher. Graeme, how are you?
Hi, good. Great to be here. Thanks for the invite.
No problem. So where are you speaking to us from, Graeme?
I'm actually based in the north of Spain, in the Basque region. Long story. My wife is from the region. So I'm not originally from the region, as you can imagine from my accent. I was actually born in Zimbabwe, for those interested.
Oh, awesome. So, yeah, I feel really bad about this. It feels like being a typical Brit, I'm complaining already that it's like, I don't know, 28 degrees, that's Celsius here today. I'm sorry, I can't do the conversion into Fahrenheit for everybody else. But I'm feeling like it's too hot. But it sounds like, you're born in Zimbabwe, you're now living in Spain. You must be pretty used to this kind of thing.
Well, I do live in the cooler part of Spain in the north. So yeah. But for sure, I'm definitely a warm weather person.
Excellent. So we're here today to talk about Micronaut. Aaron and I gave a very kind of probably poor introduction on my part, anyway, speaking for myself. I'd just been having a look at it today. So give us the kind of 50,000 foot view, the elevator pitch, if you like, about what Micronaut is.
Well, Micronaut is a Java framework that's obviously targeting the Java virtual machine. Now, historically, Java has been designed for kind of long-running processes. So for things like serverless and so forth, there's challenges to using something like Java because the virtual machine takes a little time to start up. And if you look at the history of Java, it's really been a case that people typically ran large Java application servers and left them running, and servers weren't coming and going and so forth. So, like as is the case with microservices or serverless. So in a world where you need to be more efficient, Micronaut is a new take on a framework for the Java virtual machine. And what it does is uses what's called ahead of time compilation to kind of pre-compute the way your application works ahead of time so that the startup time is faster, the application is more efficient, consumes less memory. And, Java can essentially be competitive in terms of startup time with things like Node and so forth. It has a whole bunch of additional features that do, for example, compile time checking and compile time processing and so forth. So it's very much about doing more at compile time and less at runtime.
And you're really targeting efficiency, aren't you? That was one of the things I noticed from some of the examples that I went through today on your site and some of the stuff I've been reading about only loading the bits that you need rather than kind of taking the sledgehammer approach and loading everything. So it's a lot about performance, I'm guessing.
Absolutely. Traditionally, Java folk and Java developers have definitely not necessarily been too concerned about memory optimization and improving things like startup time. Who cares if your Java application server takes a minute to start up if it's just going to be running the whole time? But now in a new world where there's serverless, where there's microservices that need to be smaller, in a world of Kubernetes, with virtual machines and so forth, in containers, you definitely need to be more efficient, especially in cloud computing, where whereas the utility model where you're typically charged by how much memory you consume, how long your processes are running. Absolutely, Java developers in general need to be more efficient, and there are various solutions. Micronaut is not the only one, but Micronaut is certainly one of the drivers of greater efficiency for Java applications on the virtual machine.
So why did you pick Java for this then?
So, fundamentally, Java is one of those things that people either love it or hate it. But fundamentally, Java is one of the most, if not, the most popular languages in the world. And it has a large ecosystem of existing libraries and database drivers and tools that are very mature tooling and build ecosystem. So the build tools of Java are very mature. If you compare, Java's build system maturity to the world of JavaScript, for example, where it's like chalk and cheese. So Java certainly is a mature platform. With large developer availability, and at a language level, the static compilation, it's one of those languages that you can build highly maintainable applications. Now we can have a debate about static versus dynamic typing, but certainly a large number of companies have found that building applications in Java leads to easier to maintain applications. If you look at any kind of statistic, Java remains the most popular language in the world. There's various reasons for that. Android's popularity is one of them. Java's popularity on the server is one of them. You have companies like Microsoft who have traditionally not, invested in Java, now investing heavily in running Java workloads on Azure. Amazon investing heavily in running Java workloads on AWS, and Google investing heavily in running Java workloads on Google Cloud platforms. So, and they're doing this because it's well known that in terms of server-side development, a large portion of it in business is written in Java. So, that was the reason.
Could I use other languages with this as well? Could I mix those things in if I wanted to?
So we support multiple JVM languages. So we support Java, and we support Kotlin, and we support Groovy. So all of those languages target the JVM. So whatever you're building, we build for the JVM. We also support another very interesting project which is coming out of Oracle, called Oracle Labs, called Graal VM. Graal is a new virtual machine which it has a whole bunch of features, some nice things like, for example, a seamless interop.
Oh.
Uh-oh.
Seems like we've got a network hiccup, folks.
Right, okay, never mind. Yeah, it looks like we may have. Let's see if we can... Oh, we're getting some interesting zoom-in effects going on now. All right, we're back anyway. So, yeah, I was just about to ask about Graal VM. I've just been looking it up. This is an Oracle thing. You don't want to tell us anything about this, do you, Aaron, by any chance?
This is after my time, unfortunately. I was just looking it up, though. It does look like it's an open source project. So I was trying to figure out if it really is. I mean, I'm always skeptical with things from Oracle, even though I used to work there. Some of this stuff just is not there yet.
Sorry,
but yeah, it looks pretty interesting. Oh, it looks like we've got our guest back.
Well, hello, Graeme. Can you hear us?
Yes.
Aha.
I am here.
Excellent. And
Jeff.
Yeah, it looks like we may have Jeff as well has joined us. Okay. It looks like, yeah, we're on a different Hangout, I think. Anyway, never mind. Let's carry on. So we lost you, unfortunately, during that. So if you could tell us a bit more about, we were talking about Graal VM and how that links in. So I was just grilling Aaron about it, which unfortunately is totally unfair because it's after his time at Oracle, but I was trying to grill him about it. So now that you're back, tell us a bit about Graal VM, and then I'll be able to have a chat with Jeff as well.
So Graal VM is an interesting project in that one of the features that it allows is the ahead of time computation of Java into native machine code. So there's a number of reasons why that may be useful. One of the things is you can, essentially an interesting new project out there is that you can pre-compute a Java application into an iOS application, for example. But part of this, the Graal VM tool suite is this native image tool. And the native image tool in Graal works very well when your application is able to be statically analyzed. Now, Micronaut is built in a manner where it doesn't use any reflection in Java or any dynamic class loading, which makes it very easy to get it operable on Graal VM and produce native images. The native images that are output then consume only a fraction of the memory of a normal Java application. So, for example, around 15 megabyte of memory instead of 75 megabyte of memory. And the startup time drops from, say, 700 milliseconds to around 20 milliseconds, which is that kind of level of startup time. You're then starting to compete with languages like Go and so forth, which provide that kind of startup time out of the box.
Excellent. That sounds really, really interesting. And during when you came back on there, people who are watching the video of this will know what's going on. For anyone listening to the audio, let me explain. I think we've now got Jeff on the line as well, if we're right. So let me introduce first. So Jeff Scott Brown. Jeff, can you hear us?
I can. Good afternoon.
Hello. Awesome to talk to you. So where are you speaking to us from?
I am in St. Louis, Missouri, which is where object computing happens to be headquartered. I'm here in the mothership.
Excellent. In the mothership. And you've got some nice banners behind you. Again, I keep saying about people on the audio. Apologies to anyone just listening to the audio. He's got some Grails banners behind him, which people on the video will be able to see, and some Micronaut stuff as well, which is great. So, Jeff, what's your relation to the project then?
Yeah, so Graeme and I are co-founders of the Micronaut project. I am a partner here at Object Computing. Of course, we're the folks who develop and support both the Grails and the Micronaut frameworks.
Excellent. How did you become involved with it then?
How did I become involved with Micronaut? So we created Micronaut So Graeme and I have been working together for a long time, more than a decade now, most of that time on the Grails framework. And a couple of years ago, so I guess we started development on Micronaut maybe almost 2 years ago, late in the summer of 2017, I think. We started building the thing. So it's not so much that I got involved in it as much as we, as an organization, created it and have been developing it and supporting it since then.
All right, and so so it's now that we've got two guests, this is great. So we can get twice as much information out of you, maybe. Who knows? So we've been asking. So Graeme's been telling us a bit about Micronaut and the background to it, what it is, how it works, and so on. So Jeff, I'm going to throw one at you. How does it differ from other frameworks? Why would I pick Micronaut over, I don't know, one of the many other frameworks that are out there? What's the advantages?
Yeah, so there are a number of, so there's a lot to that. So if we relate Micronaut to frameworks like, say, Spring Boot is a common framework that folks often relate Micronaut to. There are a number of things that I think are compelling about Micronaut, in particular with respect to Boot, and a lot of it has to do with the fact that we're able to configure most of your application at compile time and not rely on any runtime reflection or dynamic proxies, and that considerably contributes quite a bit to startup time. We're able to get the dependency injection container up and running very, very quickly, more quickly than we could if we were doing a lot of reflection. And at runtime, performance can be noticeably faster, in part because, again, we're not using dynamic proxies. We're configuring all the proxies at compile time and creating real classes that can instantiate at runtime, but are not dynamic proxies. So performance is a big part of that, of one of the benefits that Micronaut has over a lot of other frameworks. And related to that are small memory footprints. So a small kind of empty hello world Micronaut service can run in as little as about 10 megabytes of heap. And of course, depending on what your application's doing, you might have to allocate more than that. If you're allocating lots of stuff, you've got to have a place to put it. But it's totally practical to run Micronaut services with something like 16 meg of heap, maybe 32 meg of heap, certainly not 500 meg or 2 gig, like some frameworks might call for. So fast, small processes, code simplicity, those are among the things that I think are compelling about the framework. And
yeah, that's awesome.
Open source, we distribute the framework under the Apache 2 software license, so there's no runtime cost or any license cost of any sort associated with Micronaut.
I mean, I think this is great for people that want to, speed up the instantiation of their applications and reduce the memory size for sure. But Graeme, without maybe getting too technical, like what are you actually doing to make that happen? Like how do you go about it? I know this is like probably a much larger question than I'm making it out to be, but I mean, what exactly are you doing in Micronaut that allows you to reduce that the size of the runtime as well as the memory allocation?
So as it happens, different languages for the Java virtual machine, whether it be Ruby or Kotlin or Java. All of them have a way to plug into the compilation process. And what we've done is we've written a general abstraction over languages to kind of expose an API onto the source code. So what we do is we analyze the source code of your application. And what we're able to do then is by looking at your source code, kind of pre-compute how the application is wired together and constructed at compilation time. So that, a traditional Java framework, for example, would wait until the application was already running and then do kind of analysis of the kind of objects or classes that are in memory already. And it's that analysis that, consumes additional memory and contributes to slowing down startup time. Since we've removed the need for that analysis, that runtime analysis, by pre-computing and kind of wiring your application together during the compilation phase of your application, things can be a lot faster and consume a lot less memory.
Okay, cool. No, thank you for that. In fact, just as we were talking, NS Geek in the chat room wanted to know what kind of, if there's like an average performance increase, or what's the expected performance increase in terms of percentage. Do you have a average, or it probably depends on the code, obviously?
Yeah, it definitely depends on the code. Depends on a lot of factors.
It depends.
A percentage. Go ahead, Graeme.
Yeah, it depends on so many different factors. I don't know if there's an exact percentage we can point out to. Some folks have come up with benchmarks where they've like created like 1,000 classes and compared it to other frameworks. And in that benchmark, actually, Micronaut does not add that much value because if they're just empty classes doing nothing, the bottleneck there for Java is actually loading the classes. It's not anything else. But if you have, most applications that I work with typically have code in them, i.e. you have a class that has like 500 lines, like a source file that has like 500 lines. And, if you don't have to analyze those, maybe within those 500 lines, it's got like, 50 functions and 10 fields or local variables, whatever. If you don't have to do the analysis of those 50 functions or methods in Java, that's what they're called, all the fields, then you're going to start seeing some definite, improvements in terms of your startup time, because the framework doesn't have to go, okay, this is a class at runtime, or this is your type at runtime. I'm going to traverse through all the different, the structure of the class to figure out, what does what. That stuff is already done at the beginning. So there's, we don't tend to talk about percentages, and also we find it better if folks do their own comparison. I think if folks try Micronaut out, they will see the difference immediately. It's obvious. One really great benefit is that traditionally in Java, people have not wanted to write functional or integration tests. People tend to write a lot more unit tests than functional tests, and for the fundamental reason that it's expensive to spin up the whole application. So imagine you have a web application and it takes like a minute to start up. It's going to be very tedious if you have to write a test that you're going to run repeatedly again and again, and each time it runs, it's going to take a minute to spin up your whole application. But what we found with Micronaut is, because the functional tests run so quickly, starting up the application in a few hundred milliseconds, it's a lot easier for users to write better tests, write more functional tests that exercise their whole application. So there's some very obvious tangible benefits that people get to using Micronaut, and they can see immediately out of the box without having to do much analysis.
Right. I mean, it occurs to me, I used to be a data guy, right? So I worked for a lot of storage companies, and we used to get the same question actually with compression, right? People would ask, well, what kind of percentage of compression should I expect? Is it 2-to-1? Is it 3-to-1? And it's like, well, depends on your data. If you're compressing a text file that has lots of white space and duplicate characters, it's going to compress down pretty well. But if you're compressing some sort of video file, trying to compress a video file with lots of random bits and bytes,
so there's lots of variables there.
Yeah, exactly. So it sounds very comparable to that analogy anyway. I wanted to ask too about C, because what I see, in my interactions with developers is that there seems to be a resurgence in C for this very reason, which is people want to write certain types of applications closer to the metal so that they can run faster with a smaller footprint, right? And so a lot of people are going back to C. So this seems like it could be a way for people to still be able to use Java, but still get those same benefits. Is that true? Do you see that as well?
So I think when you pair Micronaut with something like GraalVM, which translates the Java application into native machine code, that is essentially getting them much of the benefit of going to something like C. I think people are looking for being able to build smaller processes in applications that consist of many processes, whether they be serverless functions or microservices. A comparison I often talk about to Java developers is, imagine if something like Kubernetes or Docker, which many of us run on a daily basis on our local desktops. Imagine if either of those systems had been written as a set of microservices in Java. Using a framework like Spring or Jakarta-E or whatever. An application like Docker or Kubernetes is probably made up of like 30 or 40 microservices. If you have like 40 of those running locally, you're going to need a supercomputer as a laptop, to run 40 processes that each of which consume gigabytes of memory. You need those 40 processes to consume only a fraction of memory. So I think that's a lot what is driving the move towards going to more native, in that you can create more optimized, smaller processes, and that's happening in the Java world as well. There's interesting progress with things like I said with GraalVM and Substrate, and yeah, for a subset of problems, there's certainly a lot of interest now. Java is very broad. I don't want to generalize Java because Java is used in so many different places, in so many different cases, from Android apps to server-side, Java apps to Kafka applications to Cassandra is written in Java, Kafka is written in Java, big data, all big data. Majority of big data processing applications like Hadoop and so forth are written in Java. So there's many cases where they still benefit from the way Java is structured now, but there are a subset of problems, which is like microservices and serverless, that do benefit from going native and going smaller in terms of processes.
Right. And that's what I wanted to ask about next. So I'm really glad you ended up with that nice little transition for me, which is that a lot of people are moving. If they're already running microservices, they're not in the cloud, they're moving those to the cloud because that's easy. And then as they refactor their applications for the cloud, they're a lot of times splitting out either into microservices or microservices and a serverless component as well, like AWS Lambda. And I noticed that, obviously the benefits here, I think, are obvious for anyone running serverless, right? But I'll let you explain it. I won't explain it. This is about your project. So explain why this is important for customers that are running in the cloud, and specifically for customers that are running, or people that are running serverless applications in the cloud.
So I think the cloud utility model, you're paying, especially in the serverless space, where you're paying per execution, and the computation of the execution on something like Lambda is based on how many hundreds of milliseconds your function took to execute, and how much memory it's consuming. So in that model, certainly it brings, it highlights more the need to be efficient, like we've just been talking about, in terms of startup time and in terms of memory consumption. So something like Micronaut can work well in a Lambda scenario, even when it's written, when it's just Java, because with a Lambda deployed to AWS, in our benchmarking, executing between 200 and 300 milliseconds, and then if you go the GraalVM native route, it's down to only sub 100 milliseconds for the execution. So that again, that affects your billing model and exactly how much you're paying per execution and so forth in a Lambda environment. But cloud is more than just serverless. In terms of cloud, Micronaut has a whole bunch of features that make it. One of our taglines is actually natively cloud native, because the cloud native term has been so overused that we thought we would just have a little play on that as well. But anyway,
what are those things that are built in? Are they? I mean, what exactly is built into this to help cloud native? If you're running in a cloud native environment, is it the deployment or just getting back to the speed and the memory footprint?
No, it's more than that. It's related to deployment. So, for example, when you push a Micronaut application to any of the cloud providers, whether it be AWS, Azure, or Google Cloud, Micronaut will actually detect the environment it's in. So it'll detect that I'm running on AWS or I'm running on GCP, and that's significant because one of the features that Micronaut allows is the kind of dependent automatic reconfiguration of your application based on the environment it's running in. So you can declare a class, type that is only relevant for GCP in the Google Cloud or only relevant in AWS, and you can have it automatically adapt based on the environment without anything extra.
Wow, this is exciting all of a sudden. So I could I use that functionality in my code? So I could say like, if I'm running on Google Cloud, then do this.
Yeah, absolutely. You can say this type requires GCP, and it will only run on GCP. And you can say this type requires AWS, and it will only run on AWS. So you can have this adaptive application, and you can have like fallback for local development and so forth when you're not running in the cloud. It's completely adaptive to running on the cloud environment. And then we have also integration with many features that the cloud providers provide. So, for example, on Google Cloud, we have integration with things like Stackdriver for distributed tracing. So if you want to, do distributed tracing in your microservice app, where you can kind of monitor which service calls, which can trace the whole call through your microservice infrastructure, we have integration with that, and a whole bunch of things. So there's really a whole bunch of cloud-specific features. That another one is we have support for on AWS. Support for distributed configuration with AWS parameter store. Also support for Kubernetes and so forth as well, automatically detecting the Kubernetes environment and adapting to that. So if you were deploying to things like Google GKE, which is the Google Kubernetes engine, or the Microsoft one, we will detect the fact that you're running in Kubernetes, and you can adapt your application to that as well.
Yeah, so around the environment detection stuff, you can have imperative logic in your program that says something like, if I'm running on Google, then do this, else do this. But in addition to that imperative support, you can declaratively express some things like Graeme mentioned. You can mark a bean with an annotation that says only load this bean if I'm running in the GCP environment, or only load this bean if I'm running in the AWS environment. So you can do things like have an interface and have different implementations of that interface, one for Google and one for AWS, and then Micronaut can help load the one that is appropriate for that environment. And related to that, we've got support for things like the default configuration file for your app is application.yaml, and we support other formats. You can have application.json and application.properties and some other formats. But so you can have application.yaml, and then you can have application-gcp.yaml, right? So that config only gets loaded if you're running on GCP. So if you've got different database URLs or any configuration that is dependent on the environment you're running in, the framework provides a really, really simple mechanism for you to express that.
Yeah, that's great. One more question. I know Dan's chomping at the bit probably to get back in on this conversation, but I do have one more question around this, and I'm sure we could talk for hours. But especially with serverless, one of the things that I find people complain about a lot is cold starts for serverless applications. And I'm just kind of curious, is there anything here that would help with that problem?
Yeah, I think, we've already brushed quite a bit on the startup time and the cold starts issue, but certainly with the GraalVM native support in Micronaut for things like AWS Lambda, we provide out of the box a AWS custom runtime, which I think last year in AWS they introduced the support for custom runtime. So we have a custom runtime which allows the construction of a GraalVM native image to implement your Lambda, which is pretty cool because you get the kind of native cold start time of sub 100 millisecond execution for your function, with while still being able to write it in Java and then to be participate in other aspects. And then even if you don't use GraalVM native, Micronaut startup time for regular Java is pretty good. It's around about 200 milliseconds. It's not as good as, for example, if you went for JavaScript, but certainly good in terms of Java.
Yeah, an interesting note about the serverless stuff is we were at Google Next in San Francisco earlier this year, and Google Next is when Google announced the Google Cloud Run platform, their new serverless platform. So it was announced at the conference, and I think later that day, it was either later that day or early the next morning, we published some samples and some documentation for how to publish Micronaut services to Google Cloud Run. And so it was really, really simple to do. For that particular thing, we didn't even have to make any changes to the framework. The framework was already sort of enabled to support this platform that we didn't even know existed until it was announced. And so it's really, really simple to deploy Micronaut services to environments like that.
Even know we're there before they arrived. That's the best way to do it, isn't it? That's really good. So I wanted to ask a bit about how we've talked a lot about the technical side of things and all the advantages and stuff. If I wanted to get started with Micronaut, how would I do that? I see you've got training, you've got other stuff. How would I get into all of this?
Yeah. You want to speak to that, Graeme?
Yeah, sure.
Go ahead.
So the official website is obviously a good place, micronaut.io. We have a great set of documentation where we put a lot of effort into writing several 100-page user guide, which provides a lot of detail on using the framework fundamentals. And then if you go to guides.micronaut.io, there's more focused guides on using Micronaut for different scenarios, whether that be to deploy to the cloud or to write message-driven microservices with RabbitMQ, or a whole bunch of different subjects that are more focused, data access with different database access tools. So those are really useful for individual focused tutorials with examples as well.
Mm-hmm. Excellent. And I've just been looking through your GitHub repos. I see that you're on GitHub. Can people commit to this? Do people contribute to the project, or is it mainly in-house?
No, it's completely open source. We've already had well over 100 external contributors, probably approaching 200, I mentioned. Haven't checked recently. And it's all on GitHub, indeed. So it's all up there and open source. So fork the repo, send us pull requests, and help us evolve the software. We'd love to have your contribution.
That's perfect, because one of our big things on this show, obviously, is we like to hear about projects that are really working with the community and working collaboratively, as I believe anyway, speaking personally, that open source should be done, and it's great. So one of my other questions was going to be, do you accept pull requests and so on, but you've already answered that. So people, if they're interested, can check out the code, as you say, fork it, work out some stuff, add some cool stuff, submit it to you guys, and see how it goes. So how many people are working on, and what kind of team have you got working on this? And how many people are on it in-house?
So in-house, Jeff, how many people make up the Micronaut team now?
Yeah, so folks on the girls in the Micronaut team, there are 18 folks on the team right now, and not all of them are working full-time on the framework, of course. So we've got folks supporting clients, doing application development with Micronaut, and supporting clients around around their Micronaut endeavors. So we've got so Graeme is the technical lead of the project, and as he's also the technical lead of the Grails project. And James Klee is our man who's kind of has become Graeme's right-hand man for development around both Grails and Micronaut, and has done just a tremendous job in the years that he's been here at Object Computing. We really can't say enough great things about the work that James is doing. And so we've got a whole team of engineers who support the framework, either in the form of doing client work, and maybe when they're between client projects, working on the framework, working on documentation. But the Grails and Micronaut team proper here at OCI is about there are 18 of us on the Micronaut team, and the Micronaut team, Grails and Micronaut team, is a subset of Object Computing as a whole. We've got about 170 engineers all together in the organization.
Excellent. So, yeah, so there's a lot of people. That's amazing. So, what about on the who's using this then? What who are your main? Well, I suppose you can't tell us too much about your clients, but you know what I mean. Who's doing? What have you seen that's cool that's being done with this right now that you're excited by?
We've seen a lot of really great stuff. So I was on site with a big retailer here in the U.S. Anyway, they're a big retailer. Just a week before last, and they're a giant organization with lots of teams. But one of the teams that I was working with told me that they had gone from Spring Boot to all Micronaut all the time, and their primary motivator was their runtime costs in their cloud environment. They found that the Micronaut services they were deploying to Google Cloud were considerably less expensive than what they had been paying, and a lot of that has to do with the small memory footprint of the services. They're able to allocate machines with much less memory. We published a case study earlier this year or late last year. I forget the date now, but we published a case study with SmartThings. SmartThings is pretty well known. Kind of smart home devices is what they manufacture, and they implemented a significant part of their infrastructure with Micronaut last year. But before we even released 1.0, they were having tremendous success with the technology. And we worked with them to publish a case study, and we can get you. Can we? Will you post like show notes, and we can put some links in the show notes? Can you do that?
Mm-hmm.
We can get you a link to the case study. But if you just Google for Micronaut SmartThings case study, you'll find it. So Micronaut is a general purpose framework, right? It's not a framework for the retail industry or a framework for the aerospace industry. It's a general purpose framework, so it's being used in lots of industries, and it's really a lot of, to be honest, it's a whole lot of fun to see the success that folks are already having with the technology. We just released 1.0 in October, so at the time of this recording right now, it's July, the first. It's about the first week of July. And already folks have a lot of major companies have adopted the technology and are having success with it, and it's a lot of fun. I've never really discussed with Graeme, but Graeme, how do you relate this to where the same experience that we saw with Grails a decade ago? I remember being really excited. It was really cool. I remember Pepsi was the very first public-facing site that was developed with Grails that I knew about, and I thought, holy cow, this is the coolest thing I'm ever going to see. And every time you hear about a new big company doing stuff with our tech, it's sort of that same feeling over and over again.
Yeah, absolutely. It's I would say that Micronaut is ahead of where we were with Grails at the time. It's been faster uptake, and Grails took a while to get on ahead of Steam, and Micronaut's been very well received, and a huge amount of people excited about it.
Excellent. I mean, it sounds like it's going really well, and it's great to see that people are getting excited about it, and it's taking off. Now, you mentioned about releases there. I was looking on your website earlier, and I noticed that the release candidate, the first release candidate of 1.2, Micronaut 1.2, Graeme, I think you published this. I was going to ask you what's coming up that you're excited about, and I have to ask, although I'm sure you probably can't tell us, any idea when 1.2 is likely to hit the release?
So I don't anticipate it being too long. I imagine the time frame we're talking about is weeks rather than months. We already issued 2 release candidates and don't tend to issue that many. So I imagine it'll be out soon. in terms of what's new, we're really excited about the new validation support because the previous versions of Micronaut relied on an external library to do validation, and the problem with relying on an external library is as soon as you pull in an external library that's not built in Micronaut, it kind of pulls in some of the old way of doing things with Java. And with Micronaut 1.2, we built a validation library that uses all of our pre-computation logic to pre-compute how validation rules apply to your application so that it doesn't impact startup time, memory, and so forth. So now then when you apply validation rules, it's very common when accepting input from, some random user that you want to validate that a particular field or whatever is of a particular pattern or is not blank or whatever. So those rules are now, how those are applied and how those are computed it's done compilation time now, which is very cool. And then the other thing we're really excited about is on the cloud side, we have support for OpenID Connect in Micronaut 1.2. So it's now very easy to add authentication to your application and integrate it with things like Amazon Cognito or Keycloak or whichever OpenID Connect provider you may choose. So that's pretty cool. And that will certainly make it easier for users who want to add authentication to their applications.
Excellent. So lots of cool things coming, it sounds like. And you guys are working away on it, and it's good to see. Now, unfortunately, we are running out of time. We've almost come to the end of the kind of time that we have for today. But is there anything that we didn't get to or anything that you want to make sure that our listeners and viewers know about Micronaut?
Well, there is one thing. We do have a interesting announcement coming up next week. If you head to the website, there's probably a news announcement somewhere, or maybe we can put it in the show notes. But we have a webinar coming up next week, which is going to announce a brand new feature, brand new more than a feature, really, brand new usage of Micronaut that is going to solve a particular problem that many developers have in a new innovative way, using all the good stuff we talked about before, the pre-computation and so forth. And I think developers are going to be very excited about it.
Excellent. So lots of cool stuff coming up, and people can check. There will be links in the show notes to the project, of course, but it's micronaut.io if people want to find out more. Everything's there on the website, which is great. Now, before we finish, I do have to ask you, we have Randall, who's the regular host, has 2 questions that he asks every guest. And if we don't ask these questions, we will get angry emails from listeners who are like, why didn't you ask those 2 questions? So let me ask you first. Graeme, I'll start with you. So what is your favorite scripting language?
Groovy, of course. Groovy is maybe a lesser known scripting language, but it's a scripting language for the Java virtual machine. I heard the word, heard Python mentioned various times. Python is a great scripting language. So Groovy takes a lot of inspiration from Python and kind of brings it to the Java virtual machine. Groovy is a great project as well, and used in a whole bunch of scenarios, from the Gradle build tool to Jenkins pipelines and all sorts of things. So, and of course in Rails, which is the other framework that we developed. Group. Yeah.
Sounds good. And what about your favorite text editor? What's your favorite text editor?
Wow, that's I tend to, for pure text editing, I tend to still stick with Sublime text. But I do put it in vi mode. So I add the vi mode editor. So I don't know if that adds any kind of kudos to my
that totally counts, at least for me. Not so much for Randall, but that counts for me. So.
Yeah, the standard. Randall loves Emacs, so that's he's not here, so he will explode somewhere in the chat room later, but that's fine. So we're both good with that. And Jeff, I've got to ask you the same two questions. What's your favorite scripting language and editor?
Yeah, the scripting language, of course, has got to be Groovy, right? So we help maintain Groovy. We've been deeply involved in the project and the community for almost the language's entire life, so that's kind of an easy one. The text editor, so I use Atom a lot, and I like that. I don't even know if it has a VI mode, but I don't use VI mode in Atom. So I think we should get a little bit more street cred with the long beards in that category. But I use Atom pretty much every day. And I like Atom.
I'm with you on that one.
Good.
Yeah. I like Atom as well. I've got it open right now, working on that problem I was talking about earlier. So, love it.
Excellent. That's brilliant. All right, and so all right, we're running out of time, unfortunately, guys. But it's been really good to talk to you. Great to hear about Micronaut, and I'm sure we'll hear from you again. You know, you've got this great announcement coming next week. I'm sure at some point down the line we'll come back and see how you guys are doing when you've taken over the world of frameworks and stuff. You can come and tell us some more about that. So a big thanks to Graeme, and thanks to Jeff as well for talking to us. Nice to talk to you. All right, and so that was Graeme Rocher and Jeff Scott Brown talking about Micronaut. So web framework, JVM, targeting, all that kind of stuff. And actually, some of the really interesting stuff that we got to there as well, which was the way you can programmatically choose things based on what cloud platform you're on. So Aaron, what did you think?
Well, that's what I'm most excited about. And they're obviously not the only framework that does that. But I think it's really cool because this is solving a problem that I think is being exacerbated by as people start moving to the cloud and reducing, their, monolithic applications into microservices and things like that, and using serverless. So they're really solving for a real problem that exists today, not just in the Java world, obviously in the Java world, but not just in the Java world, but also when people are deploying applications to the cloud, this becomes much more pronounced. And so, so I'm really excited about it. As luck may have it, we did not time this. In fact, I was not even planning on being on this show. I'm not a Java guy, but I'm going to share this with several people at work. As soon as we get off here, I'm going to Slack them and say, hey, are you using this? Do you know about it? And as luck would have it, at AppDynamics, just a quick plug, we just actually released support for AppDynamics on AWS Lambda yesterday. Actually, I don't even know if the announcement's gone out, but you can find it on the AWS Marketplace. So that's a perfect companion with this, actually, to be able to monitor these applications, not just run them, but if you want to monitor them, now you can use AppDynamics. So the timing couldn't be perfect. And so I'm definitely going to go, I'm sending this right now to my Java PM, the PM that runs our Java agent for APM. I'm going to send this to him and say, hey, do you know about this? Like, we need to get in on this goodness. So yeah, I'm really excited about it, if you couldn't tell.
Yeah, it's excellent. Don't you love it when things just come together at the right time, naturally? I nearly said I love it when a plan comes together, but somebody else famously said that long ago. So yeah, awesome. So yeah, great stuff. Keep an eye out on Micronaut. You can find out more at micronaut.io and look in the show notes for this show. So I should tell you what we've got coming up as well. We have in the coming weeks, Randall should be back, we hope. And on July 17th, Wednesday, July 17th, it's OSCON, and I think Randall's going to be at OSCON live from the event, and he's talking to, and I apologize in advance because I'm probably going to get this name wrong, pronounce it wrong, but I will try and get it right. He's talking to Rachel Roumeliotis. I think it's Roumeliotis. I apologize if I've got that way wrong, Rachel, if you hear this or see this. But yeah, she will be on with Randall and possibly another live co-host. Many other people from the show might be there as well. You never know. So that's coming up on July 17th. Then on July 31st, we've got Gareth McCumsky, who's going to be talking about serverless framework, which is everything's serverless these days. It seems to be the big thing right now. So much more to talk about on that. And there'll be loads more guests coming coming up as well. If you know of a project that you think should be on the show that hasn't been on the show or you haven't seen yet and you want to see them on the show, that sounds great to us. You need to get in touch with them. Ideally, get in touch with the project leader or somebody who can, somebody of influence at the project, and have them contact Randall. They can do that by emailing merlin@stonehenge.com, which is great, and he will get through that. And it's a really good way of jumping high up the list of our upcoming guests. We've got loads of cool things coming up. So if you think of something, don't be afraid to get in touch. You can see who's coming up on our spreadsheet, which you can actually get from the website. If you go to twit.tv, look up Floss Weekly. It's in the notes there. You can watch us live and listen live every Wednesday when we do the taping, as we are now. And you can talk in the chat room. Many people talking away. Thanks to everyone in the chat room who got involved today. If you want to get involved on IRC in the chat, you can do that as well. And follow us on Twitter. If you go to @FlossWeekly, that's @FlossWeekly. That's where you can find us on Twitter, which is awesome. I think that's about it for that bit. But I want to quickly mention as well, while I'm here, that I'm one of the organisers for an event called OggCamp, which is the largest community free software open source event in the UK. It's our 10th year this year. Hard to believe it's been that long, but it's our 10th anniversary this year, and we've got an event coming up in Manchester in the UK. Obviously, that is in October. It is on the 19th and 20th, the weekend of the 19th and 20th of October 2019 in Manchester, UK. You're all invited wherever you are. I don't know where you are, but if you're welcome, if you can get yourselves here, come over. Tickets are available now, and they're available on a completely kind of pay what you want basis, including zero. You can come along for free. We're totally good with that. Everybody gets equal treatment. And you can also go and find out more at oggcamp.org. That's oggcamp.org if you want to find out more about that, or find us on Twitter and other places. And I'm sure I'll bore you with more about this on a future show before we get there. But get your tickets now, because they're going pretty quick, and we hope to see you there. So, Aaron, is there anything you want to plug?
Yeah, I'd love to come to OggCamp, though. It's something that I've always wanted to do. How many people typically attend?
About 400 to 500. So, I mean, by the time, in terms of it's pretty big. In terms of, say, FOSDEM, which is like 8,000. Okay, I admit they're quite a bit bigger. But as far as UK goes, we get quite a few people. We've got some good talks lined up.
Wow. Do you have a good arcade in Manchester? That's the question. If I want to go play some retro games.
Yeah, there's actually a retro gaming club there, I believe. So I'm doing my best to try and tempt you across the waters to come and
I'm
visit.
getting more and more interested as we're talking. So I don't have a whole lot to plug. It's kind of a quiet season in the summer. One thing I will say, though, if you're looking for a good book to recommend for people that are just buying the new, can I center that up? There we go. The new Raspberry Pi 4 that just came out with all of its issues that are going on right now. Eventually it'll be a good single board computer. But if you have people that are buying that and they know nothing about Linux, that's a great book to go out and buy. My book called Linux for Makers. It's available on Amazon and wherever else you want to buy it. That's the only thing I want to plug. Really, I'm enjoying the quiet summer, kind of catching up from the busy spring and the upcoming really busy fall that I've got going on. So, yeah.
Excellent. Well, thanks for giving us some of your time, some of your summer time, and joining me on the show today. It's always appreciated.
Yeah, you bet. I'm always glad to be on with you. We ought to do this more often. Just kind of have the co-hosts get together and be able to catch up.
Yeah, that's true. The lunatics have taken over the asylum. And on that note,
right.
I think we better wrap it up before we run out of time. So thank you very much, and we'll see you next time on Floss Weekly.